So good morning, everyone. I will start to present our system we designed for solving the challenge problems. So I'm Nali from Swiss Federal Institute of Technology in Switzerland. And so the title of presentation is Magnifico. This is a system we designed. It's a platform for expert mining using the metadata we got from Mendeley corpus. So just an overview of what kind of task we need to solve. So we have a crowd of people and their information and the profile and the publications. So the thing we need to do is that we need to find from this huge crowd that people having subject matter expertise. So what we do is we take users' query as input and we'll analyze their query and try to understand what kind of expert they want to find. And then we return a list of experts that having this exact expertise of the user query. So first, we got the Mendeley dataset. It contains profiles, publications, and the reader statistics of these publications. We need to first pre-process this data because it's not like perfect. So what we did that is first we crawl additional metadata, including disciplines of the authors and the readers, and also the academic status of the authors, because later on we need to further group the authors and experts into different groups according to their academic status. So the next thing we do is that we kind of need to filter out the noises in the dataset. So we first deal with the inconsistency in the dataset between different entities. Like some authors, their name could be not completely consistent in authors and in their profiles. Sometimes they omit their middle name or they just use their abbreviations, things like that. So we need to deal with this inconsistency. And also, so in our system, we only consider the English entries. We got a lot of, quite a few entries in other languages, and we need to filter them out. So we use this Chrome library to detect the language of the entries and try to get rid of these non-English entries. So the next thing we did is to solve the problem of identity resolution, because as we know that for the data set we have, for each publication, we have a list of authors, but we only know the author names. We don't know what profile they have and which profile is there. For example, if you search for my name, Nali, in Mendeley, you will got like 100 or something. You don't know which one is the real me. So what we did is we use the name to search for the profile. But if we got like more than one names matched, we use the co-authors disciplines to filter the noise authors out. So the next thing I want to present is the most important thing is what kind of approach we use to get these experts. So basically, our steps is like that. So first, we get the user's query, and the first thing we do is that we need to understand what users really want to find, what kind of dominant disciplines are in this query. So this is the first step. And the next step is that once we know the dominant disciplines of the query, we need to pick out these experts in this data set who has this who has this expertise in those disciplines. So to solve the first problem, we use a modified TF-IDF approach. So the original TF-IDF is term frequency inverse document frequency. So here, so the TF-IDF, basically the idea is that it measures how important a term is for a given document. So instead of doing that, what we did is to measure how important a term is for a certain discipline. So we changed the document into discipline. And to do this, we try to infer for each document, for each publication, we try to infer the discipline distributions, the probabilities this publication could fall in which discipline. And the metrics we use is that, okay, not time up. Okay, so because for each publication in the dataset, we know that there's how many users from which discipline. For example, we might have one publication has like 10 users from, 10 readers from information retrieval discipline, and 5 readers from, I don't know, artificial intelligence, something like that. So we believe that this reader discipline is kind of is a good indicator to say that what possible disciplines this publication is talking about. So for instance, as we can see here, there's author, he has a publication, and this publication has 5 authors, 5 readers from information retrieval discipline and 10 from artificial intelligence. So what you get is that this publication could be talking about both information and IR and AI with a certain probability. So now what we get is that we have the discipline distribution for each publication, but we all know that each publication is a combination of a set of words. It's a combination of words. So we want to know that what discipline distributions are for each word. So what we did is that we collect all the words in each publications, and then of course we need to filter out the stop words like the, as, for, all these not very meaningful words. So we filtered all these stop words out, and then we compute the discipline distribution for every word. So in the end, what we get is a matrix that's showing what disciplines these words could be talking about for every word. Of course, we need to do normalization of this distribution, because in the dataset we have some documents for some disciplines. They have lots of documents. Of course, they have lots of words. And some disciplines like art or literature, they have less documents. But like biology or computer science, you have a huge list of publications. So we need to do some normalization to the results we have. And of course, we also need to filter out some common words that appears everywhere in every discipline, because for every discipline, in many disciplines, they all use like analyze, model, or all these kind of not so discipline-specific words. So what we did that we tried to measure the frequent, how frequently these words appear in across all the disciplines. So once we get this, we need to filter out the word that appears everywhere, which is not so discipline specific, because it will create noise in the later phase. So now we have a matrix that's showing the discipline distribution for every word. And imagine now we have a query. So what we do is that we know that for each word in this query, what kind of discipline they fall into. So we compute the discipline distribution for this whole query. And then we choose the dominant discipline by choosing the highest the score, the discipline that has the highest probability. And sometimes user might be interested in searching for cross-discipline queries. So we also deal with this. If we have like several disciplines that more than one, that they have both very high score, and they are the high score, they are very close to each other. We keep them all because there might be cross-discipline queries. For example, some users might want to search for HCIR, which is like HCI plus IR. So it's not like just one discipline. So to sum up, what we got that now is, So what we have now is we use a modified TF-IDF approach to analyze users' query, and we get the output is the dominant disciplines. The next step we do is that we know these disciplines, but we need to select users from the crowd who has this expertise in this discipline. So to do this, we need to use the repetition metrics that measure how important or how famous, how proficient this people are in different fields. So again, we use the reader count of their publications as a measure of their popularity in that discipline. So for every author, we try to count the reader count in their publications in different disciplines and to sum them up to measure how proficient they are in this discipline, as we show here. Like an author has 2 publications from, the first publication has 5 readers from IR and 4 readers from AI. And the other one is 3 readers from IR and 3 readers from AI. So to sum up, this author has 2 expertise. One is IR and one is AI with different scores. So, so in the end, what we have is that we take users' query as input, and we infer the dominant disciplines for the query, and then we use the repetition matrix to generate a list of authors sorted by their expertise score. Okay, so now I'm going to show the demo of the system to show how our system can solve the 3 problems in the challenge. I don't know if there's...
Magnifico is a search application that helps you to find people with subject matter expertise. Now we will show you how Magnifico works using 3 search scenarios. We first would like to search for a list of candidates for a job. Skills required for the job is user experience design, product design, user interface. We want only master and bachelor students in the results. Enter the keywords and click to search. Magnifico guesses that your query falls into the field of industrial design. Here is a list of people having their corresponding expertise sorted by their expertise score. For each person in the list, Magnifico also generates an expertise cloud indicating his major strength, the collection of his publications, and a Magnifico score showing how proficient he is in a particular discipline. Click on his name. You will be redirected to his Mendeley profile page for future contact. Now we filter the results to keep only master and bachelor students. Next, we would like to find keynote speakers and program committee members for the Strata conference. We search for experts in 2 different fields. 1, business intelligence and business strategy. 2, information retrieval, web systems, and information systems. For the first query, 3 disciplines are suggested, and a list of experts in those disciplines are displayed. Not satisfied with the search results? Use the filter to choose the disciplines you want. Now, we search for the experts matching the second query. The next thing we want to do is to find suitable people for delivering a patent research. The keywords of the patent are distributed computing resources and distributed systems. We will further group the candidates by their academic status. Enter the keywords and click to search. A list of candidates having at least one of the suggested expertise are shown. Want to see people having all the suggested expertise at the same time? Click to switch the results. Click again to switch back. Use the filter to keep only students who will deliver the patent research. Or select more senior experts who are more credible in high-stakes litigation.
Sorry for the French accent. So this is a demo, and the next thing is that at the time for the challenge is very short. We didn't manage to finish everything we want to do. So here are the future work we are planning to do that we will continue to do this. So currently we use the text mining approach is TF-IDF, but now later on we would like to try other text mining approach like LDA topic model that can infer the latent topics in these publications and the profiles, and to try to compare which approach performs better, and also now we only use the content of the metadata of in the corpus. We didn't consider the social network data like membership, co-authorship, and things like that, and connections between people. So we believe that if we can integrate this part into the model, it will help to improve the results. So we will do this also. And also we need to evaluate our approach. So yeah, I would be glad to answer all the questions if you have. Thanks.